So today we are going to start this new topic on fractions. So we'll be starting from the very basics. Say why do we need a fraction, how to represent a fraction, and then we'll go on to the advanced level wherein we will be able to solve some word problems that involves fractions. Okay. So before we go into solving questions on fractions, we need to know why do we need fractions. And if I have fractions, how do I name fractions and how do I identify which part involves a fraction and which does not? Okay, so in this first module, we'll just try to understand how do we represent a fraction. Basically, we'll be using the fraction bars. So if you have seen a fraction in the past, so a fraction is represented like this. So this is the fraction bar that we use to represent a fraction. Other way is also to use shapes. So for example, if I have a circle, I divide it into two equal parts and shade this one particular part. So this way also I can use to represent a fraction. And then when we are dealing with fractions, so just like numbers, there are different types of numbers. Similarly, fractions also have different types. Two of them being mixed fraction, improper fraction. We also have proper fraction. So we can interchange these two. So we can convert mixed fraction to improper fraction and improper fraction to mixed fraction. So we'll also see how do we do that and how does a mixed fraction and an improper fraction looks like using shapes. Okay. So first of all, why do we need fractions? We need fractions whenever we have to divide something into equal parts. So this equal part is very important when we are dealing with fractions. Right? Say we have this burger, we have this chocolate. Say, so we have divided this burger into two equal parts. And we have divided this into 8 equal parts. So 1, 2, 3, 4, 5, 6, 7, 8. So both the cases we are dividing it into equal parts, right? Say 2 equal parts, 8 equal parts, we can have 10 equal parts, 20 equal parts. So whenever we have such cases wherein we are dividing something into equal parts, we use fractions to represent it. Okay. And how do we denote it? Say when we are writing fractions, we need to see what part we are interested in. For example, if I just look into this, I may be interested in this particular slice or this particular slice. Right here, I may want only one slice. I may want two slices, three slices, four slices. So, what is the part that I am interested in is very important when we are dealing with fractions. Right. So, the first thing is how many equal parts we are dividing anything into. So, for example, if you look at this part, this circle, we have divided it into three equal parts. This triangle is divided into three equal parts. And this rectangular shape is divided into three equal parts. So all these three figures that we have are divided into three equal parts, which means we can use fractions. Okay. So the figures shown, so all the figures that we are seeing here have three equal parts and a shaded part. This information can be represented as a fraction. So we need the following information to have a fraction. The first thing is a figure must be divided into equal parts. No matter how many parts we are having, but all the parts must be equal. And then we should have a part wherein we are interested in, say, a shaded portion. Okay, then we can use that information to inform a fraction. So how do we write fraction? So the first thing is there are components in a fraction, right? So we have a component that is known as numerator, we have another component that is known as a denominator, and this is a bar, right? So it separates the numerator and denominator. First thing, denominator. So we're discussing what are the important things that we need. The first thing that we need is we need to divide it into equal parts. So how many equal parts I am dividing this figure into? It is 3, right? So denominator would be 3. Denominator means the total number of equal parts that I'm dividing a figure into. Okay. And the numerator means the number of shaded parts or the number of parts that I'm interested in. Okay, so here I may be interested in the shaded portion. I may also be interested in the unshaded portion. So if I'm interested in this shaded portion, my numerator will be 1. If I am interested in this unshaded portion, my numerator will be true, 2. So it depends on what part we are interested in, our numerator will change. Denominator remains constant, which is equal to the number of parts we are dividing into the figure into, right? Or number of equal parts. So these are the components of a fraction. So again, we have a figure. So how do we represent the figure as a fraction? Again, we are dividing this into 4 equal parts. So the denominator is 4, right? And the numerator, again, if we are interested in the shaded portion, then we have 3 parts, right? So 3 parts are shaded. So this will be 3. If I would have been interested in this unshaded portion, so numerator would have been 4, and the number of equal parts that I have divided this figure into would be 4. So 1 upon 4. Okay. Okay, we have some questions, some basic questions with fractions, or how do we write fractions. So circle the fraction that matches the picture. Okay, so we are given a shape, then we have to find out which of the following fractions does it represent. So first of all, we'll identify denominator. Denominator means number of equal parts I have divided this figure into. So 1, 2, and 3. So denominator is 3. Right, most of the time we are interested in the shaded portion only, until and unless it is specified in the question that we need to find the fraction of the unshaded portion. Okay, here the shaded portion is 1 and 2. So 2 parts are shaded out of that 3. So 2. So this means that 2 out of the 3 parts are shaded, right? So I divided this figure into 3 equal parts and then shaded 2 of them. Again, if we look at this question, again, if we have to write the denominator, we'll see how many equal parts I've divided this figure into. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11. So I've divided this figure into 11 parts. And then I have 1, 2, 3, 4, 4 shaded parts. So 4 out of 11. So I divided a figure into 11 equal parts and then shaded 4 of them. So 4 out of that 11 is shaded. So this is how we represent this figure into a fraction. Okay, so having known fractions, we now can try to understand the different types of fractions that we can see in our daily lives, right, or see around us. The first type of fraction we have is the proper fraction. A proper fraction is a fraction wherein the numerator is smaller than the denominator. So if you look at this particular fraction, if I have to write it in terms of fraction, so I have divided this triangle into 3 equal parts and shaded one of them. Right, so again there are 2 components in a fraction, numerator and denominator. If numerator is smaller than denominator, right, so it looks practical because if I'm dividing it into some part and then shading it, numerator must always be smaller than the denominator. Right, so that is why it is known as a proper fraction, because this is how a fraction should look like, wherein I've shaded some part inside. Right, so for example 1 upon 2, if you look at this, the numerator is smaller than the denominator. Here also the numerator is smaller than the denominator. Here also the numerator is smaller than the denominator. So all 3 are examples of proper fraction. If we look at improper fraction, it is the opposite of proper fraction. It does not look like a proper fraction. So it is a fraction whose numerator is greater than its denominator, right? So for example, 3 upon 2, 11 upon 4, 13 upon 8. All these cases, you see the numerator is greater than the denominator. So if it is not possible to write an improper fraction in a single figure. We need more than one figure to write an improper fraction. So improper fraction is always accompanied by a whole part. So how do you represent this number? So this means how many equal parts I am dividing a figure into. So it is 3. Notice that I will not write 6 equal parts, because when we are dealing with fractions and when we are writing the denominator, we only write how many equal parts I am dividing one figure only. Okay, so I'm dividing a given figure into 3 equal parts. You can also consider this as how many parts makes up a whole. Okay, so 3 parts makes up a whole. So this is the denominator. And then how many parts are shaded? So 1, 2, 3, 4. 4 parts are shaded. Right? So if we combine both of them, this becomes an improper fraction. Otherwise, this was a proper fraction and this was a whole fraction. We call this as a whole fraction. So this is 3 upon 3, wherein I have shaded this entire fraction. So it becomes a whole fraction. Right? Whole fraction can also be represented as 1. Okay. Then we have mixed fraction. So mixed fraction is again similar to improper fraction. So the only difference is that mixed fraction, I can consider this as a whole part, right? So I can consider this part as a whole because I've shaded this entire portion. So this can be considered as 1 because I shaded 3 out of 3. So this became 1. And then a fraction. So it combines a whole number and a fraction. That is why it is known as a mixed fraction. We have studied what whole numbers are. Now we are studying what fractions are and what happens if we combine both of them. So if we combine both of them, it becomes a mixed fraction. For example, this is one whole part, and what is this fraction? So one part is shaded out of the 3. Right? So if I have to write a mixed fraction, it means one whole part and then 1 upon 3 fractional part. Right? So we are combining whole part and fraction part. So that is why it is a mixed fraction. Okay, so notice that these two are the same thing basically. Right, so that is why we are able to convert improper fraction to mixed fraction and mixed fraction to improper fraction. We'll see an example in the subsequent slides. So what are some examples of mixed fraction? 1 and a half. So we call this one whole part and half fractional part. 2, 3 upon 4. Right, so 2 whole part, 3 upon 4 fractional part. 1 whole part, 5 upon 8 fractional part. So this is an example of mixed fraction. Okay, so how do we write mixed fractions? So if you look at this figure, right, so it has one whole part, two whole part, and a fractional part, which is 3/5. So we call this as 3/5. Why? Because 3 out of that 5 is shaded. So this means 3/5. If I have 2 out of 3 shaded, so it means 2/3. Right? 1 out of 5 is shaded, 1/5. So this is how we name a fraction. Just like we have number names, this is how we name a fraction. Right? So this is a fractional part. So we call this 3 and fifths. So 3 out of that 5 part is shaded. Right? So if I have to write this mixed fraction in numeral form, so I have two whole parts because this entire figure is shaded. So that is why one whole part, one whole part. So two whole part and one fractional part, which is 3 upon 5. Because 3 out of the 5 is shaded. So 3 upon 5. Okay. How else we can write a mixed fraction? We have already seen that a mixed fraction is similar to an improper fraction. So we can also write a mixed fraction as an improper fraction. We'll see how. So here we just saw this example. This was 2, 3 upon 5. Now instead of considering this as a whole, I can divide this into 5 parts. Right, just like this, I'm dividing these two also into 5 parts. Now what will be the denominator? As we know, denominator means number of equal parts we are dividing one figure into, not the entire figure. So this will not be 5 plus 5 plus 5, 15. So this will be, we just need to, for denominator, we just need to look into any one of the figure and then see how many parts make up a whole. So 1, 2, 3, 4, 5. So we are dividing one figure into 5 parts. So 5 is the denominator. And then how many parts I'm interested in? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 is the numerator and 5 is the denominator. So this one was mixed fraction. And if you notice, this fraction is not a proper fraction. Why is it not a proper fraction? Because the numerator is greater than the denominator. For a proper fraction, numerator must be smaller than the denominator, which is not the case. So this is an improper fraction. Okay, so we can write a mixed fraction into improper fraction, but again, drawing figure every time is not the correct approach, or it is not efficient. So we have to use numerical methods that can be applied everywhere. Let's say I have the same mixed fraction. how do I convert it to improper fraction without using the figure? Right, so the first step is multiply this whole part with the denominator. So the step 1, multiply the denominator and the whole number. So 2 5s are 10, right? So we wrote 5 times 2. So we are multiplying the whole part with the denominator. So this is the first step. Then what is the next step? Once we are done with the multiplication, we add this numerator. So multiply the whole part with denominator and then add the numerator. Right? So 5 into 2 gives us 10, and then we are adding the numerator, plus 3 gives us 13. Right? And we should keep the denominator as it is. We should not change the denominator. So we'll get 5 in the denominator. So I'll get 13 upon 5, which was the same answer that we got using the figure method. Right? Again, we'll look at some more examples to make it more clear. Now, we can also do vice versa. For example, this is an improper fraction because the numerator is greater than the denominator. We can write it in forms of mixed fraction. Right? Say, for example, here, if I have to write this as an improper fraction, how do I write this? So the first thing I'll notice is that how many parts make up a whole. Right, or how many parts I've divided my figure into. 1, 2, 3, total number of equal parts. So 1, 2, 3, 3. And then what is the number of parts I'm interested in? 1, 2, 3, 4. So 4. So 4 upon 3. It is an improper fraction. Another way to represent this is because all the parts are shaded, so I can just consider this as a whole triangle. Right, so this becomes 1. 1 is a whole part. So when everything is shaded, it becomes 1. Right, and then this is 1 out of 3. So I can write this as 1, 1 upon 3. Okay. Again, we have this figure method. This is just for interpretation of how this is working. Right. We'll also have this numerical method that we can use to convert an improper fraction to mixed fraction. We have seen how to convert mixed to improper. We are now doing improper to mixed. Okay. So what do we need to do to convert improper to mixed? We just have to divide the numerator by the denominator. Right. So numerator will be here, denominator will be the dividend. Denominator is the divisor, numerator is the dividend. So we are dividing the numerator by the denominator, and then we get a quotient and we get a remainder. Right, so anytime we are doing this, we'll get a quotient and a remainder. Right, the first thing we'll do, we'll write the quotient here as the whole part. So quotient comes here. Then we have remainder. Remainder comes here, and the denominator remains as it is. Okay, so what we did, we first divide 4 with 3. So we got 1 as the quotient and 1 as the remainder. So the quotient we are writing here, the remainder we are writing here, and then the denominator we are writing here. Okay, so now we'll just see an example to see how this works. Right, so the first thing is we are given a mixed fraction. We need to identify what type of fraction we are given, and we have to convert that to improper fraction. If I have mixed fraction, I can convert it to improper fraction and not proper fraction. Because proper fraction cannot be converted to mixed fraction, because proper fraction does not have any whole part. Improper fractions have whole part. That is, it can be converted to mixed fraction. Okay. So here again, what were these steps? The first step was multiply the whole part with the denominator. So I'll do 3 times 5. So 3 times 5 is 15. Right. Next step is add this numerator. So I'll do plus 2. Right, so 3 5s are 15, plus 2 is 17. So 17 will come here and the denominator will be as it is. Okay. And this is an improper fraction, so I'll be able to convert this to mixed fraction. Right. So 9 upon 2. So I just have to divide 9 by 2. So 2 4s are 8. Remainder is 1. So quotient we write here. Remainder we write here. Denominator remains as it is. So 4 1 upon 2. Right? Notice why we cannot convert a proper fraction to mixed fraction and vice versa. So proper fraction can be like 2 upon 3. Right? Now we know that to convert an improper fraction to mixed fraction, we need to divide. Now if you divide this 2 by 3, we'll get 3 zeros are 0 and then 2 as the remainder, right? So if I have to write this in terms of a mixed fraction, it will be 0, right? What is the remainder? Remainder is 2 and then 3 will be the denominator as it is, right? So you can see the whole part is 0. So there is no point in writing this whole part, right? So it does not make sense. When the whole part is 0, we do not write it. So that is why even if we try to convert a proper fraction to mixed fraction, it will remain as a proper fraction. It will not get converted. Okay. Again, a quick recall. So we have a fraction. When we have a fraction, we have two components, a numerator and a denominator. Denominator means how many parts we are dividing a figure into. Numerator means the number of parts we have shaded or we are interested in. Right, so this is an example of a proper fraction. Then we have a mixed fraction. Mixed fraction means a whole part and a fractional part. Right. Improper fraction means the numerator is greater than the denominator. Proper fraction meant the numerator is smaller than the denominator. Right, so we can convert a mixed fraction to an improper fraction, and we can convert an improper fraction to a mixed fraction. Right, so you can try solving this to an improper fraction and see what do you get. You can try converting this to a mixed fraction and see what you get. Okay. So, I mean, when we are discussing this classification of numbers, right, or fractions into proper fraction, improper fraction, mixed fraction, we are just looking at one fraction at a time. When we see two or more fractions, right, then we have a different classification. Right, so that is known as like and unlike fractions. So if I give you two or more fractions, right, then you can classify them as like and unlike fractions. When I'm just giving you one fraction, you can call that this fraction is a proper fraction, this proper fraction is an improper fraction, or this fraction is a mixed fraction. But if I give you two fractions, you can say that these two fractions are like fractions or these two fractions are unlike fractions. Right, so what is the definition? So like fractions are two or more fractions that have the same denominator or the same number of parts that we are dividing the figure. So if you look at this, I've divided this figure into 4 equal parts. I've divided this figure into 4 equal parts. Although the number of shaded portions are different, still the number of parts that I'm dividing this figure into is the same. So for example, this is 2 out of 4 and this is 1 out of 4. Right? So this means they are like fractions. So like fractions are the fractions that have the same denominator. When we have like fractions, it becomes very easy to compare two fractions. It becomes very easy to add to fractions, subtract to fractions. Right? Whereas unlike fractions, we have to do some further manipulation. Okay, so understanding what like fractions are helps us save a lot of time by simplifying the calculation. Whereas unlike fractions, the calculations are a bit tedious. So what are unlike fractions? Unlike fractions are two or more fractions that have different denominators. So if you look at this figure and this figure, here you have 3 as the denominator because we have divided this figure into 3 equal parts and 2 is the numerator. Here you have 1, 2, 3, 4, 5, 6, 7. 7 equal parts. So 7 is the denominator and 4 is the numerator. So if we compare these two, you can see that their denominators are different. So that is why they are unlike fractions. They are not similar. Right, so these two are like fractions, these two are unlike fractions. What are more examples of like fractions? For example, 1 upon 11, 4 upon 11, 3 upon 11. So these three, all three of them are like fractions. However, if you look at this, 1 upon 8, 3 upon 4, 5 upon 9. So these are unlike fractions because the denominators are different. Okay, so this understanding of like and unlike will help us in comparing numbers and then doing computation operations. Okay, so Now that we know the fundamentals of what numbers are and what fractions are and what are the different types of fractions, we'll move into simplifying fractions. How do we simplify fractions? What are equivalent fractions? And then further we'll study comparing fractions and then do computation operations like addition, subtraction, and multiplication with word problems. Okay. So in the next class, we'll start with equivalent fractions and simplifying fractions.